Hello and welcome to exam questions number 9 in the series for permutations and combinations. So in the first question we have the letters of the word radian written on 6 separate pieces of card. If we pick 4 cards at random, what's the probability that within the cards we've picked we have just one letter A? So first we're going to write down all the different combinations we can get with the letters from radian. And as you can see, there's only one combination where there are no A's present. We have these 4 combinations here where there is one A present, but we have to times it by 2 because we could have A1 there or A2. So that gives us 8 combinations where there's one A, and these 6 combinations where we have both A's present. So the total is 15 combinations, meaning the probability of having one A present is going to be 8 over 15. Of course, if you want to find the total number of combinations, you could have also used 6 choose 4, used the combinations formula, put the numbers in, and also got to 15 combinations. However, you would still need to know how many combinations of those only had one A. In this question, we have 7 tiles, 3 pink, 2 blue and 2 red, and they're placed in a straight line. And we need to find the number of arrangements where the pink tiles are together and the blue tiles are not together. So if we write down the arrangement like this, where the pink tiles are together and keep them as one group, we effectively have 5 tiles to rearrange. So the number of arrangements is 5 factorial, but we have to divide by 2 factorial, 2 factorial, because there are 2 blue tiles and they can be switched and the arrangement is still going to be the same, and the same for the red, they can also be switched. So there are 30 arrangements. And next we're going to work out how many arrangements there are if the pink tiles and the blue tiles are together. Now if we group the pink tiles together and the blue tiles together like this, we effectively only have 4 items to rearrange. So the number of arrangements in this case is going to be 4 factorial, but we have to divide by 2 factorial because we have 2 red tiles, and if they're switched, the arrangement will still be the same. So that gives us 12. And then if we subtract the amount of arrangements where the pink tiles and blue tiles are together from the total arrangements when the pink tiles are together, then we'll get the number of arrangements where the pink tiles are together and the blue tiles are not together. And this is 30 minus 12, which equals 18. And in the last question, we have the letters from the word butter written on 6 separate pieces of card. We're selecting 4 at random and laying them out. What's the probability that the 4-letter arrangement begins and ends with a consonant? Well, first we're going to work out the total number of ways to select 4 letters, which is 6p4. So using the permutation formula, you get 360. You could, of course, also use the multiplication rule that we discussed in previous videos, where you have 6 choices of letter for the first place, 5 for the second, 4 for the third, and 3 for the fourth. So if you times 6 by 5 by 4 by 3, you also end up with 360. So next we're going to write down all the different ways we can pick 4 letters and have a consonant at the beginning and the end. So to start with, we're going to have a T at the beginning and at the end, and we're going to call them T1 and T2 to differentiate them. And in this case, we have B, U, E and R left. So we have 4 choices for the second letter and 3 choices for the third letter. This gives us 4 times 3 or 12 different arrangements where we have the first T at the beginning and the second T at the end. Then we're going to do the same with T1 at the beginning and a B at the end. This leaves T, U, E and R, so again we have 12 different arrangements. If we now continue doing this for all the other possible combinations of choosing a consonant at the beginning and the end, we end up with 72 different combinations. However, all these letters could be switched. For instance, we could have a T2 at the beginning and a T1 at the end. Therefore, we have to times this by 2, so there's 144 different ways we could pick the cards, so there's a consonant at the beginning and a consonant at the end. Therefore, the probability is 2 over 5. Next, we have to work out the probability that the arrangement begins with a vowel. Now there are only 2 vowels, so it can either start with a U or an E. And in both cases, that leaves 5 letters to choose from for the second place, 4 for the third, and 3 for the fourth. So that gives us 60 arrangements each, which makes 120. Or if you preferred, you could also use the permutation formula, n factorial over n take r factorial, where n is 5 and r is 3, and you would also get 60. And the probability is the sum of these two, 120 divided by 360, which is equal to a third. And finally, we have to work out the probability that the arrangement we've picked starts with a B and ends with a vowel. And as you can see, there are only 2 ways this can happen, with a B and an E or a B and a U. And using the same methodology as before, each one has 12 different arrangements. So we have a total of 24 different arrangements where this happens. Therefore, the probability is 24 over 360, which is 1 over 15. As always, thanks for watching. I hope it's helping. And if you could just press that little like button just down below, that would really help me out. Thank you. Bye.